everybody, and welcome back to part two of the properties of real numbers. Last time we looked at the commutative property, the associative property, and the distributive property. Today we're going to look at three more types of properties that are super helpful when we're trying to solve problems. We're going to be looking at the identity properties, the inverse properties, and the zero property, which is kind of its own special thing all by itself. So let's get into it and learn about these other properties of real numbers.
Okay, so like I said, we're going to talk about the rest of the properties of the real numbers. Let's start with the identity properties. And you can think of these properties as the ones where the original number doesn't change. So again, let's do a thought exercise just to think about it a little bit. And let's maybe take the whole idea of numbers and math out of the situation. Think about yourself, okay? If you neither add nor subtract anything from yourself, you will never change. You will always be constant. If you never eat anything, then you would have remained a baby. Obviously, that's a little simplistic, but you get the idea that um, you will remain static if you don't add or subtract things to yourself. Okay. And then at the same time, all right, there is only one you. Your particular combination of your genetics and the life experiences that you've had can never be multiplied or truly duplicated. Even identical twins do not have the exact same lived experiences. So there is only one set of you characteristics. And so you're always going to come back to yourself. Okay. So those are a little, uh, uh, not metaphysical, but they're a little, abstract. But in terms of math, what that means is that we have two identities that always come back to the original number. Okay. So the first one is the additive identity. And so the question for yourself is, in what mathematical situation can I add some value to a number, but that number doesn't actually change? So let's write out a possible scenario, okay? And we're just going to fill in the blank space that we see here. So we have 8 plus blank equals 8. Based on all of our experience in arithmetic from kindergarten, first grade, whatever, to today, we all know that what goes in that blank is 0. So what that means for our property is that 0 added to anything is still the original value. Or written algebraically, a plus 0 equals a. All right. Then we have a multiplicative identity. So it's the same kind of question for yourself. In what mathematical situation can you multiply some value to a number, but that number doesn't actually change? Okay. So again, we have a fill in the blank situation. 3 times some number still equals 3. And again, based on our experiences in arithmetic, we know that without having to do any fancy algebra, okay, we're just filling in blanks, all right, we know that what goes in the blank should be a 1, all right? So again, as a property, we can say that anything multiplied by 1 is still that thing. Or in a symbolic way, we write it as a times 1 equals a. So, as a side note, before we move on to the next set of properties, this is why I often will say to remember that there is a ghost 1 next to all terms, variables, numbers, and groupings, okay? Since multiplying by 1 never changes something's value, it is always allowed to hang out. It's a nice ghost. It's a friendly ghost. It's Casper, if you will. So it's always there. And sometimes we need to pull it out. sometimes we need to have our ghost do something. And so it's always important to remember that that 1 is there because of this identity property. All right, let's move on to the inverse properties, or what I call getting back to basics. So if the identity properties were all about maintaining the original value, okay, the inverse properties are exercises in trying to get back to 0 or 1. All right. So again, let's think about this. What if we could have an undo button for literally anything? Okay. We said something we didn't mean, and we're like, oh, I really wish I hadn't said that. Or let's say you misjudged on some cool trick you were going to do, and instead you did a face plant and embarrassed yourself, and you're like, wow, I wish I hadn't done that. We've all had those moments, and we all wish we had an undo button. Thankfully, in a lot of our computer applications, we have the good old Control Z to literally undo something we didn't want to do. And even many email clients these days come with the ability to unsend something, especially if it's on the same network. But from a mathematical or scientific perspective, we need something a little more concrete, a little more written down, if you were, that allows us to reverse or erase or nullify a result of a process that may come up with something. How do we get back to the start? Okay. And so it turns out that all of the operations we use have inverses. They have an undo button, if you will. And it's just a matter of figuring out which operation undoes every other operation. Okay. So based on what we know from arithmetic and anything you've learned in pre-algebra, ask yourself, what are 2 sets of operations that are used regularly? And hopefully you come up with addition and subtraction, because you can use addition to undo subtraction, and you can use subtraction to undo addition. And the other set is multiplication and division. Again, if you multiply 2 things together, you can use division to undo that. And similarly, if you divide 2 things, you can use multiplication to put things back together to get back to where you started. Okay. So in that sense, okay, we can use these operations to get back to zeros and ones, which can be really helpful for solving problems because it helps get rid of the extra numbers. It strips down variables and numbers to their bare bones, because we're going to get as many of those numbers down to zeros and ones as possible. Okay. And so we have these inverse properties to help us do that. So first, the additive inverse. Okay. So again, we ask ourselves the question when we're trying to figure out what it is we need. We are going to say, in what mathematical situation can I add some value to a number so that I end up with nothing? I'm going to change this. There we go. There we go. I messed that up. There we go. Okay. Sorry. So you've got another blank space situation here. So 8 plus some number is going to equal 0. Now, this is a little bit, I think, trickier than the identity equation where we had to fill in the blank, because your brain says, if I add something to 8, how do I get to 0? Your brain wants to say, I'm not adding. I need to take away. I need to subtract. And you're absolutely right. But remember, adding a negative number is the same as subtracting. Okay. So, whereas you might have subtracted 8, you can also add negative 8. So, what we can then say is that the opposite of something added to itself is always 0. Okay. And like I said, you can also reword this as saying anything subtracted from itself is always 0. But again, it's called the additive inverse, so we're going to state it in terms of addition. So symbolically, that means we have a plus negative a equals 0. All right, let's move on to the multiplicative inverse. And again, our question to ourselves is, in what mathematical situation can I multiply some value to a number so that I get back to 1? Not 0, but 1. Okay, so this one, 3 times what is equal to 1? This might be a little trickier. Okay, it's a little bit harder to conceptualize. How do I have 3 of something that is going to give me 1? Okay, so the easiest way I think to work through this numerically is to walk through a couple of different steps. And so I've written here the thought process for solving, getting to our property. So you're going to say, well, wait a minute. If I multiply a number by itself, that is going to make it bigger. So maybe I really don't want to multiply and I actually want to divide, because division is what makes things smaller. Okay, that sounds like a good place to go. Okay, so just trying out a number, all right, I could say that if that wasn't a multiplication sign, if that was a division sign, then I would definitely put 3 in there. It would be 3 divided by 3 equals 1. But the name of this property is the multiplicative inverse. So how can I say the same thing but using multiplication? That is when we come into the situations of trying to write problems in different ways. Okay, remembering that we have at this point learned a lot of different symbols in math. We know that there are some symbols that mean the same things, and we just have to pick the right symbols for the right situation. So what if I write this division problem as a fraction? Remember, a fraction is a division problem. That fraction bar is just another type of division symbol. So instead of writing this horizontally with 3 and then the what I would call the basic division symbol divided by 3, we're going to have 3 over 3, okay? And it still equals 1. This first one here and this one here, same thing. I just used different division symbols. Okay, so now the question is, can I rewrite 3 over 3 so that there is multiplication involved? And yes, I can, because of what we just talked about in the multiplicative identity property. We know there's a ghost one hanging out with that 3 in the numerator. So I'm gonna state it. I'm gonna show it. I'm gonna shed light on it. I'm gonna throw a dot matrix up on it. You know, if you play Phasmophobia, then you'll know that's one of the tools you can have to try and detect ghosts, because you can put a dot matrix up. So same idea. Okay, I'm gonna show the one that is there. Okay, so now, okay, I can actually separate those things to the point that I can say 3 times 1 divided by 3 is equal to, sorry, this is giving me dust. There we go. Is equal to 1. Okay, and so symbolically, that means that a times 1 over a will always equal 1. Okay, so this is as close to being able to edit my Blackboard as I go along. When I notice I made a mistake, but I think that it's really important that you guys see that mistakes get made by mathematicians. We are not perfect. We make little mistakes like that. Pretty common, actually. But that's okay. There's nothing about mathematics that says you have to be 100% correct 100% of the time. It's that you learn from your mistakes or your misunderstandings. And so for me, I'll be like, okay, I need to reread these one more time before I get ready to record. But that is the multiplicative inverse property, that a times 1 over a, or 1 divided by a, is equal to 1. I have one more property to talk about today, and that is the zero property, which is a million groups of nothing and no groups of anything. I should make that the title of the book or something. Anyway, again, let's talk about this. Let's think about what it means to multiply by zero. So if multiplication takes a value and duplicates it a certain number of times, like 2 times 3 is a group of 2 existing 3 times for a total of 6 things, then how can we describe that in terms of zero? This is one of those things that I would encourage you to try to picture in your head, or even draw a representation of it on a piece of paper. But you're going to have some amount, doesn't matter what it is. And if we multiply it by 0, that means that there are no groups of that amount. So in the end, there's nothing at all. It's blank. Okay? So the total value ends up being 0. Okay? Even if you have a cajillion apples, but you don't multiply it at all, okay? You don't, they cease to exist in that lack of multiplication, because you're not even multiplying it by 1, and now you have no apples. Okay? So the zero property, short and sweet, to the point, it's that a times 0 is always going to equal 0. And since we've learned that the commutative property from our last video, we know that 0 times a equals 0 is also a true statement. All right, so those are our 3 additional properties of real numbers.
And there you have it, everybody. Those were the inverse properties, the identity properties, and the zero property. When we combine these properties with last video's properties of the commutative, associative, and distributive properties, we now have very powerful tricks and tools at our disposal for helping us to solve equations and simplify expressions. We are one step closer to getting unstuck from algebra. Join me next time so we can check out how to start solving equations and simplifying expressions here on Math Unstuck.